Today we're going to be talking about the ratio test. And this is the test that is most popularly tested on the AP. It's the one that's my students find that they tend to enjoy the most. And this is actually the last test that we'll talk about for our testing for convergence or divergence. And don't have this be your go-to test right away. Okay. And I'll talk about that with my first example. Okay, so our ratio test. So I have a series with positive terms. If you take the n plus 1th term and divide it by the nth term, and you take that limit as n goes to infinity, and you get some sort of limit. So we converge if our limit is less than 1, diverges if our limit is greater than 1, and we are inconclusive if the limit equals 1. Okay, and again, this is a super popular test. I think it's one that is most commonly used, but I've found the past few years when I've taught this, my students default right to this test. Don't default right to this test, okay? So I'm going to use the ratio test to determine whether convergence or divergence of the series so that you can see how it looks, and then I will talk about maybe a more efficient way. Because remember, one of my themes is work smarter, not harder. So limit as n goes to infinity of the n plus 1th term. So that's 2n plus 1 over 3n plus 1, all divided by the nth term. So that is 2 to the n over 3 to the n plus 1. And that's all in absolute value bars. So what I'm going to be doing from now on is I'm going to be jumping to this step here. Oh, so this should be 3n to the n plus 1 plus 1 there. I apologize. Times by the reciprocal of the bottom, 3n plus 1. I'm having trouble writing today. Okay. 3 to the n plus 1 all over 2 to the n. So like I was saying before I realized my little mistake here, is I'm going to be jumping straight to this step. So now I have to find this limit. And 2 to the n plus 1. So I'd subtract those, and you get 2 times by 3 to the n plus 1. I'm really having trouble writing that one today. I don't know why. I didn't when I took my notes. All over 3 to the n plus 1 plus 1. Okay, so as this gets really, 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 really big, I'm going to do a little bit more algebra in here just so you can see something. And then on the bottom here, I'm going to have 3 times 3 to the n plus 1. As I go to infinity, really the plus 1s don't really matter. This whole thing, oh, I forgot my absolute value signs. Ends up being 2/3, which is less than 1. So therefore, this series converges by the ratio test. Okay, next example. Oh, I wanted to talk about maybe a more efficient way. Honestly, what I would do is I would do the direct comparison test for this. I would compare this to this series. And then understanding that that's now geometric and that we would also converge, okay? So this is kind of the long way to do it. And you're welcome to do that, but remember you want to be working smarter, not harder, okay? Okay, use a ratio test to determine the convergence or divergence of this series. So, convergence or divergence of this series. A lot of times when you have this n factorial, okay, you want to make sure you're using the ratio test. Whenever you see that n factorial, that's when you're going to do the ratio test, okay? Just as a kind of a general rule. So do the limit as n goes to infinity of n plus 1 factorial all over 3 to the n plus 1 times by 3 to the n over n factorial. Okay, so let's talk about what this means. Well, 3 to the n's cancel, so I'm just left with a 1/3. Now let's review what factorials are, okay? So remember factorial, n plus 1 factorial means n plus 1 times by, now reduce this number by 1, n, reduce it again by 1, and so on, okay? And then n factorial is n times n minus 1, and so on. So what cancels? Basically the n factorials cancel. So I'm left with the limit as n goes to infinity of n plus 1 over 3. Well, as that goes to infinity, this whole thing equals infinity. So remember, if your limit was greater than 1, this diverges. Okay, when you have a mix of like polynomials, well, exponentials, and a polynomial, that's again when you want to be using the ratio test. Okay, so again, we set up our limit as n goes to infinity of 3n plus 2 over 4 to the n plus 1 times by n plus 1 squared times by, now I look at it like it's almost the reciprocal. Okay, so then I simplify that. Okay, so simplifying that. 4 to the n plus 1, or 4 to the n divided by 4 to the n plus 1. Subtract your exponents. All you are left with is a 4. 3 to the n plus 2, 3 to the n, all you're left with is a 3. And then you would have n squared over n plus 1 squared. Remember, you're looking at this as I go to infinity, so same power. This would go to 3/4 less than 1, so therefore this converges by the ratio test. Okay. Next one. Use a ratio test to determine convergence or divergence. So again, we set up our limit of -1 to the n plus 1 times by the square root of n plus 1 all over n times by n minus 1 over -1 to the n root n. As I go to infinity, and I do some simplifying, really the -1s don't really even matter. I would end up with square root of n plus 1 times by the quantity n minus 1 all over n root n. So this limit Because if I look at that as like n to the 1/2, look at that as n, kind of ignore the n minus 1, the plus 1, this would go to 1. Which means we are inconclusive. Our ratio test didn't work for this one. But I want us to think, what else could we use? Hey, what else could I use? Whenever I see this, I think alternating series test. Okay, so first, remember we have to prove that this would go to 0. Highest power on the top is 1/2. Highest power on the bottom is 1. The bottom's going to get bigger faster, so that is going to go to 0. Okay, and then we need to prove that the n plus 1th term, so the n plus 1th term, that this is less than or equal to the nth term. And I kind of struggled with proving this. So what I did is I said, okay, if n equals 2, because I'm starting at 2, I have root 2. For n equals 3, I would have root 3 over 2. N equals 4, I would have 2/3. N equals 5. Don't like that equals there. That's technically not mathematically correct. I would have root 5 over 4. Obviously, hopefully it's obvious to you that all of these numbers keep going down. So like this one is 1.414. Square root of 3 divided by 2 is 0.866. 2/3 we know is 0.6 repeating. Square root of 5 over 4 is 0.559. So our values keep getting smaller and smaller and smaller. Okay, so then we can say that this converges, since it meets both conditions, by the alternating series test. Okay, so that's your video on the ratio test. It is the most important test. It's a test that you really need to know when we get into something a little bit later on in the semester or in this chapter in a couple sections. All right, thank you for watching.